Hey explorer, remember that first prick of a thorn you felt as a child? Ouch! Or the moment you went ow when you felt that sharp sting of the burn and instantly dropped the match you were holding for too long? Ever wondered why that sharp prick stings instantly, but a lingering headache or persistent abdominal ache seems to last forever and drive you crazy? And speaking of dealing with pain, remember as a kid how just rubbing your booboo could make the pain disappear like magic? It's amazing how a simple act like that can show the incredible power of our minds in managing pain. Well, get ready to set off on a compelling journey into the human body to unravel the intriguing mystery of pain and uncover the mind-boggling science behind how your body experiences and interprets different types of pain. Are you ready? Let's dive in. First things first, what is pain? In medical terms, pain is defined as an unpleasant sensory and emotional experience associated with actual or potential tissue damage. Whether it's a sharp sting or a dull ache, short-term acute pain like a sprained ankle, or long-term chronic pain such as arthritis is never exactly fun to deal with. Don't you agree? But here's an undeniable truth. Pain is essential for your safety and well-being. Yep, your pain is the brain's way of telling you, hey, watch your back. It acts as your body's alarm system, signaling potential harm and urging you to pay attention and take necessary action before it could lead to further injury or damage. For instance, when you touch a hot stove, you feel a searing pain and reflexively pull your hand away. Now, imagine if you didn't feel that pain. Your flesh could be cooking and you might not even be aware. This is actually the reality for people with congenital insensitivity to pain, or CIP, a rare genetic disorder. With CIP, you could place your hand in boiling water or undergo surgery without anesthetic, feeling no discomfort at all. A life without pain sounds like a blessing, doesn't it? However, for individuals like Betts, a 21-year-old university student, it's more of a curse. People think not feeling pain is amazing, almost superhuman, he says. For us, it's the opposite. We'd love to know what pain feels like. Without it, life is full of challenges. Here's a heartbreaking story of a young Pakistani boy with CIP known in his community as a street performer. He could walk on hot coals and stick knives in his arms without flinching, a testament to his insensitivity to pain. Sadly, this remarkable ability led to tragic consequences. In his early teens, he lost his life after jumping from a house roof, highlighting the severe risks faced by those unable to perceive pain. Isn't it fascinating to realize pain is more than just an unpleasant sensation? It's your body's built-in warning system, nudging you to avoid repeating mistakes. This crucial role helps you regulate physical activity, assess risks, and protect yourself from harm. Moreover, pain isn't just a signal of danger, it's a catalyst for healing. By forcing you to rest and giving your body time to recover, pain guides your actions towards a safer, healthier path. But that's not all. Did you know your brain can sometimes trick you into feeling real pain, even when there's no injury or damage at all? Hard to believe, isn't it? Consider the case of phantom limb pain, where individuals who have lost a limb often report experiencing excruciating pain in the limb that is no longer there. How can you hurt when there's nothing to hurt? It's quite a mystery, isn't it? Well, let's delve into the interesting case that occurred in 1995, sparking a significant shift in our understanding of pain. A 29-year-old builder accidentally stepped onto a 15-centimeter nail which pierced straight through his steel-toed boot. He experienced agonizing pain, making even the smallest movement unbearable. Yet, when doctors removed his boot, they were stunned. The nail had never even touched his foot at all. His brain had generated intense pain purely from the sight and thought of injury. This bizarre case revealed that pain can be generated purely by the brain, much like the phantom limb pain. Oh, and don't forget the placebo effect. People experience real pain relief from a sugar pill they believe is medication. This shows how our thoughts and beliefs can significantly alter how we feel pain. Isn't it beyond astonishing how much influence your mind has over your experience of pain? Are you now curious to understand how your body perceives pain? let's dive into the miraculous way the nervous system detects and interprets this vital sensation. Imagine strolling through a vibrant garden, soaking in the beauty of blooming flowers and lush greenery. As you reach out to touch a velvety pink rose, a sneaky thorn pricks your finger. Ouch! Your nervous system springs into action, instinctively causing you to withdraw your finger. It all begins with these vigilant microscopic guardians known as pain receptors or nociceptors, which are specialized sensory nerve cells strategically positioned in your skin, bones, joints, muscles, and organs. The nerve endings in your skin act like spies, watching for anything noxious that could cause actual or potential damage to your tissues. A sharp pinprick, extreme heat, or a forceful crash all can set them off. The central axon, a swift messenger, is a slender and small diameter fiber capable of two forms: the fast, myelinated A delta fibers racing at 6 to 30 meters per second, and the slow, unmyelinated C fibers with a slow pace of about 0.2 to 2 meters per second. These tiny defenders work with one mission: to watch out for anything noxious in the environment that could potentially harm your tissues and swiftly sound the alarm. The signal we interpret as pain. Quite a remarkable defense team, right? Well, let's meet the 3 squads of nociceptors, each designed to respond to different types of noxious stimuli. First, the thermal nociceptors, ready to jump into action in response to intense heat or cold stimuli. Think scalding hot water or freezing temperatures that could cause frostbites. Next, say hello to the mechanical nociceptors, the pressure crew, chiming in when something heavy takes a liking to your foot. Ever been pinched or crushed? Sudden pressure like that can set it off too. Lastly, let's meet the chemical nociceptors, your taste testers for spicy foods and the aftermath of a chilly rendezvous on your skin. It's like having a superhero squad right inside of you, each with their unique superpower. When your finger is pricked by a noxious thorn, the special squad of mechanical nociceptors springs into action, triggering a relay race of information. The pain signals travel through their nerve fibers, referred to as first-order neurons, to a special group of neurons outside your spinal cord called the dorsal root ganglion. From this ganglion, the nerve fibers relay the message baton to another group of neurons inside your spinal cord known as the dorsal horn. Here's the fascinating part. Your spinal cord now takes the center stage with its dual role. Being a quick decision maker, it sends the command to the muscles of your hand. Instinctively, your finger is withdrawn from the thorn. This is an involuntary reflex action happening even before the pain signals have been relayed to the brain. So basically, you will have pulled your arm away even before becoming conscious of the pain. That's quite intriguing, right? At the same time, like a courier on a mission, the second-order neurons from the dorsal horn of the spinal cord sends the message to the brain's thalamus. The thalamus, being the brain's sorting hub, directs the message to different areas of the cerebral cortex of your brain for further processing. One of these areas is the somatosensory cortex, a key player in the brain's sensory processing, which takes on the task of recognizing the intensity, quality, and the localization of pain you're experiencing. Is it a sharp poke, a dull ache, or a radiating pain? But the cerebral adventure does not stop there. The pain message also makes its way to your frontal cortex, the brain region responsible for various cognitive functions, including memory. Here, the frontal cortex delves into its memory bank, searching for any familiar pain sensations from the past. Think of it as your brain's own archive, helping you recognize and interpret the pain based on your past experiences. The thalamus also dispatches the message to the limbic system, the emotional heart of your brain, giving your pain a personal touch. Picture a childhood memory where you experienced a sharp pain while handling thorny flowers. The fear and discomfort from that incident are now intricately linked to the current pricking pain. Research shows that if your limbic system is silenced, the ability to learn from past painful experiences diminishes. But if you've undergone such an experience, the thought of reliving it might be daunting, right? So, through this complex process, the thalamus ensures that the pain message is distributed to the right departments of your brain, where it undergoes analysis, interpretation, and even a trip down memory lane. It's a remarkable example of how your brain collaborates to make sense of the complex world of sensations. The end result is that you feel a sharp pain localized in your finger. Ouch, what was that? You might also feel a bit irritated, thanks to your limbic system. And all this happens in the blink of an eye. So next time you wince, remember, it's your body's relay team at work, turning a simple touch into a full-blown ouch. Next up, do you ponder how does your brain interpret different pain sensations? Why a needle prick feels like a sharp, lightning-fast sting, while the burn from inflammation after an injury is a slow, lingering discomfort? And that deep, persistent ache in your abdomen seems to have no specific location? Let's now unravel the mystery of how your brilliant nervous system decodes these distinct pain sensations. When a needle pricks you, the A delta fibers of the nociceptors spring into action, sending lightning-quick signals to your brain. This sharp, stinging pain is like an urgent message. Pay attention right here, ouch! It's your body's quick response system, precise and localized. Now, when it comes to inflammation or burning skin or dull ache on your back or knee, a different set of nerves takes the stage. The C fibers, slower but steadier, convey a diffused, slow onset pain that persists. Your body sends a slow burning signal, saying something's not right and it needs a bit more consideration. Aching pain, often emerging from deep within your viscera or muscles or joints, follows the same slow C fibers. Unlike the sharp sting, this pain isn't localized. It's a constant, annoying reminder that demands attention. It's like your body's persistent alarm, signaling that there's an ongoing issue that needs addressing. In essence, your nervous system decodes these pain signals based on the type of nerves involved, their speed, and how your brain interprets the intricate language of pain. So, as you can see, pain is our living, breathing alarm system that reminds us we're still alive, alerting us to potential dangers and guiding us towards a safer path. As we bid adieu to the intricate world of pain, let these words resonate. If I woke up in the morning and nothing hurt, I would worry I was dead. Still fascinated about how the human body deals with pain and injury? Check out our video about what happens when you break a bone.